Alright, so if we do this in class, it's only going to take us about 20-25 minutes. So on here, it should be less than 10. Candace, which is my wife's name by the way, made 32 ounces of a fruit drink using pineapple and grape juice. And it talks about some specifics here. The number of ounces in the pineapple juice is 5 more than 2 times the number. In the last chapter we talked about something, in the last section we talked about 5 more than 2 times. So in other words, if I call X pineapple juice and Y grapefruit juice, well, I know that the pineapple plus the grapefruit was 32 total ounces. I also know from what this says that the pineapple juice is, so the pineapple juice is, equals means is, 5 more than 2 times the other one. Okay? So I can take this and substitute it in right there to solve for one variable. 5 plus 2y plus y equals 32. Combine my like terms. And you know how to do this. Minus 5 to both sides. And divide to get y to be 9. Okay, so it says how much of each should she use though. So if I plug 9 into here, subtract it to the other side, I see that I get 23 ounces of pineapple juice and 9 ounces of grapefruit juice. I don't use P's and G's because they look like 9s and other things that they shouldn't. Anyways, down below, this is the hardest problem of all of these. It is what you remember as linear programming, or maybe don't remember as. I'm going to graph these lines and I'm just going to sketch them. I mean, y is greater than 4. This is the y-axis, this is the x. Y goes through the y. So here is the line y is equal to 4. Greater than means if I plug in 0, does it work? Nope. So I have to shade away from 0, 0. All of this stuff up here. Okay. See if I can find a different colored pen here. Yes, I do have one. Alright. For the other one, x is less than 10, I'm going to put a line over here. Okay. 0, plug it in, it works, so I shade towards 0. So I can see kind of already where my region kind of is. And then it says x plus 8 is less than or equal to 8. Remember, that's the cover-up method, so y is 8, about right here. X is 8, about right here. And I connect those dots. I don't have a straight edge, so I'm going to do my best here. It's just a sketch anyway. What I want to know are, okay, so is it less than? I plug in 0, 0. I get 0 is less than or equal to 8. That's true. So that line shades here. So here is my feasible region, right here, that I need to test into the objective function. So if you remember, it's just finding the value of these points. This should be really easy. I know that's over 0 and up to 4 where that line is. So that's the point 0, 4. This point should be really easy because we know that that was y equals 8 from when we did the cover-up method. So that's 0, 8. And this point, well, one thing I do know because it's y is 4 is that the point has a y value of 4. And if it has to be intersecting with this line, plug 4 in here. Take it to the other side, you see 4, 4 is the other point. And I plug those into the objective function under x and y. So 10x minus 2y, plug in 0, get 0 minus 8 is negative 8. It says to maximize, that's probably not going to be it. 0 minus 16, well that's for sure not it. 40 minus 8, yeah, that would be a maximum right there. There's your answer. Okay, simple as that. Next problem. Paid $300 a week plus commission. Okay, so 300 plus, yep, that happens on all these. This is just a process of elimination type of problem. If she sells $200, she receives 5%. If she sells 200 or more, so less than 200, 200 or more, she receives 8%. What can be used? Okay, so or more means it can be equal to it or more, which means that can't be it and that can't be it right off the bat because I don't have any less than or greater than or equal to signs. Then it's just a matter of putting it together. If it was over 200, so that, it better go with 8%. And that doesn't, whereas that does. right? And if it's less than, she makes, well, less than goes with it. Okay, so there's my answer, just process of elimination. Not much math to do there, okay? The other side, the first problem there, I hope you could see that when I was doing that.
Did you see that schedule line?
Right there, okay?
The week after?
So, up at the top here, example 4, the grocery store offers the coupon for $2 when a customer buys 6 bottles or more. That's kind of the key to this whole problem here. The water costs $1.75 per. The function here is given to find the total cost to buy B bottles of water. Okay? She's got $5. She finds that B is approximately 3.4, which means she thinks she can buy 3 bottles of water for $5. What's the error she made? Really, there's a couple of different answers here. Number 1, she only gets the $2 off if she buys 6 bottles. If she's buying 3 bottles, it says right here it costs $1.75 per bottle. Well, $1.75 times 3 is $5.25, which means she doesn't have enough money. So either the store offers coupon if she buys 6 or more, or, so that's one right answer, or you could write that 3 bottles times 175 is greater than $5. And that's more than what she has, right? That's it. One of those two would be right. For the last example, a couple things. The pool is 75 feet long, 25 feet per second, going away from the wall. Create a table and a graph. Well, part of this is just reality. If I look at this graph and it says 0.75, that is 0.30 right there. So that automatically can't work. I can just keep going from there. This says 0.75, that's graphed there. This says 0.5, that's graphed there. This says 0.75, that's... Okay, so I can mark out 2 right away, just based on the graph and the chart. Okay, now I've got a minus and a plus here. Just plug in numbers. Do they work? If I plug in 2 into here, 2 times 2.5 is 5. 75 plus 5 is 80. That doesn't work. That doesn't even work. So that again tells me that doesn't work. If I go up here, plug 2 in. 75 minus 5, 70. 75 minus 10, 65, and so on. And if I look, those points are graphed on this line. 270 would be, right here, give or take, and so on. Okay? Hence, that's why that's the answer. Simple as that. Less than 8 minutes. Your homework is the next 2 pages. You should be able to finish this in class if you were here. If not, less than 10 minutes for your homework, maybe 15 tops. Have a good one.